Alright, so imagine you're a Kubernetes engineer and at 3 a.m. you get a call, like you get alert interruption and you fix it, but this keeps on happening. There is currently no environment where you can train your own agent to learn about the exact incidents that happen in your environment. So we built one. We built one using OpenENV framework, and so this is our architecture. We have a Claude adversarial judge, and what this does is it interacts with the real Kubernetes cluster. We ran a Kubernetes cluster on GKE, and it injects error in the Kubernetes cluster, and the agent goes ahead and debugs it, and the Claude adversarial judge also rewards it based on the steps it took. Sid will talk to you about one run.
So if you can see, at a step we get the response from the agent. Then we also did it using the reward model, which is Sonnet model. And we actually run the command on the virtual Kubernetes cluster. So there are two modes to verify this. We are not directly verifying with the reward model. We are also getting the output from the real Kubernetes cluster. So only when the command succeeds and the pod state goes to healthy, it is rewarded. There are some race conditions here. Sometimes the pod might stay healthy for 1-2 seconds, but it might crash loop again. So we also made sure to handle those cases, like you sample 3 states at different 5 seconds, 10 seconds, 15 seconds, and also just the whole responses of the agent to make sure the incident reward is correct, not really hacky. Initially we started with a single failure. The curriculum will increase the difficulty. After fixing the single stage failures, it will introduce multiple pod failures. Then it will introduce 3 pod failures. So it was an increasing difficulty training that we have done. And you can show some results on the actual response that are better annotated. So if you can see some of the responses that it gave like a wrong command, and the judge says this is a really wrong command. And when it is able to do the correct command, the judge has positively rewarded it. The whole reward is also cumulatively sometimes used to train the RL model. And at one point, after doing even small